Okay, we begin the process by removing the carpet. Simply pull that out. There's a little Velcro here and there that needs to be removed, and then pull it out.
This tub comes out next, right, Mike?
Yep. And it's just a flexible panel that pops right out. Now, this is what you have to realize, is that there is some danger involved with playing in here, but we're going to make it as safe as possible by first removing the negative lead from the battery under the hood, and then also removing this screw and that screw, which lifts this cover. And then you'll see the red kill switch. Pull the plastic piece off, which is not easy. Flip the switch, and 5 minutes from now the car will be totally safe. We'll put this back on so it isn't flipped by accident, and we remove the small screw that's right here. It's an 8mm screw. Screw that out, and that cannot be removed until this switch is flipped, so it keeps it safe.
Battery. Interesting thing I found about this battery, Mike, is I cannot buy one from the Honda dealer that's this size.
That's right.
This is the original.
Yep.
And I'm still looking for a way to find exactly that size battery. I didn't want to go to a heavier battery.
Well, you know,
remove here.
Yep.
I'm going to go right underneath the carpeting, I guess.
Because most of you don't have an upholstery tool, I fabricated some out of some stainless steel that I happen to have, and it works pretty well.
Sticky little rascals.
Yep. Now you'll notice that there's screws all along here. These two screws are very difficult to get out because they've got a fine thread and there's very little holding them in there. So usually you have to take a Phillips screwdriver and really gently try to unscrew it. And if you're really gentle, it will unscrew, and then once you get it started so you can grab the head, just pull it straight out.
Mike and I just discovered a little trick here with his tool because it's so nice and sharp. Both of these were giving us major difficulty coming out, so with this tool I can actually go right under there and pull it.
Right. Third use to the tool.
Manual, yep. Very nice, Mike. So, now, where's this?
So that exposes
come out.
These two 10mm here that have
10
to
mil
come
in the
out.
back corners.
And then I think this thing will pop out after that. Make the rug looser and give us better access to everything we have to take out from this point on, we found that it's much better to take the seat out than to not. So let's do that next. Get your wrenches out and make sure you got at least a 3/8 set, because these things are really in there. They recommend replacing them with new bolts when you do this, but I believe if you put a little dielectric grease on them and you tighten them up nice and snug, they should be fine, but you do what you think is right. Okay, now that you got the 4 bolts out, and I know they were tough, but you know, they didn't want you to go flying through the windshield if you got in an accident. Tip the seat forward by pulling the little lever. Lean it to the driver's side while pulling the bottom out slightly. And now what you're going to do is you're going to remove the seat belt. That can also be pretty tight. Okay, now you can take your seat right out of there. Get it out of your way. Careful you don't scratch or bump the paint when you come out. And put it somewhere safe.
Filter off.
Yep.
Spin that out of the way. Move some of this stuff under the hood. Then what?
Okay, then you got these Phillips on the sides.
More on the sides. I'll grab my Phillips in that.
Just fill up right there. And at the top is the another one of those upholstery clips.
Don't bump your head like I just did. Can't see that one.
The emergency brake console goes next. Again, there's some small Phillips screws there, one on each side. Got to pull the seats forward in order to get good access to them.
Seats back again.
So once you have that rear connected, you pull forward on this,
Okay.
and it comes right out.
All right.
3 of the components that come with MIMA use epoxy putty to make the interface to the underlying surface. This epoxy putty takes an hour to set up to the point where you can handle it well, and about 24 hours to be fully cured. So let's do this early in the installation, and that way it'll be ready to take to the next stage when you get up to that point, and a lot of time will be saved. Remember, the joystick has the 2 buttons here and here, and his assist regen. So now the question is, which way do you want that to be mounted to this thing? You can mount it this way, where assist regen is here, in which case as you're driving you'd end up pulling this way for assist and this way for regen, and then you could reach down and touch the buttons here. Another way that I found actually works better for me, since the 2 push buttons are here and here. If I put this way, then assist is sliding my finger sideways like this, regen is this way, and the 2 push buttons are easily accessible from there or from the top this way. So that's what I'm going to do. That's the one I've done on my car, and I'll show you how to do that one. But you can theoretically mount this in any position you want, just remembering that since the other joystick is going to have assist opposite the wire, this one is going to also work the same way. Now, the wire itself needs to be kept under control, so what I found is that since I'm going to mount it this way, and the wire comes out the side, I'm going to fold the wire over this way, and then give it a half turn this way. So now we've got something that looks like this, and that way the wire will come right down the front of the joystick and can be brought into the boot without a lot of work. So let's put the outer cover on. To avoid getting epoxy all over the shift handle, we want to put a release layer of saran wrap. Any type of plastic wrap will work, and it's taped on with white or black tape in order to hold it in position. Now, we don't want this tape to be where we're going to be applying the epoxy, so we're going to put it on the back side like this. And we're going to carefully stretch this material, which is quite compliant, over the surface. Try to get any wrinkles out that we can. But a few wrinkles aren't going to matter much. And now we've got the thing covered with saran wrap. Now let me put another piece of tape on here to keep that all in position. Again, on the back side. And now we're ready to mix up our epoxy putty. 2 little small pieces. Don't need much. We're just trying to bridge the gap between the 2 rather than build a whole new one. So we'll just mix up this epoxy good. Mixing's important. If you don't have it mixed thoroughly, it may not harden, in which case you got a mess. And you have to take it all off and get yourself some more epoxy putty and start over again. Now you can tear this stuff, you can mix it any way you want. And remember, water acts as a release agent for this stuff. I'm going to pause for a second and go wash my hands off to get this gooey stuff off. Okay, so I'm going to start by taking a little piece of the epoxy putty off. What we're going to do with this is build a little bridge underneath so that the sharp circuit board components don't get in our way or pierce this wire, And we also give this something to hold it in position. So right there we have a little daub of epoxy, and now we're going to put the main piece of epoxy on top of it. Press it in. It's more or less the contour we're looking for. It doesn't have to be perfect because we can modify it as we put it on. So now we're going to put this right in position here. Work it in. You can see the excess material has squirted out. So what we'll do is we'll start by taping this wire to keep things in position. Okay, so now we hold it snugly against here, making sure it's not at an angle, and then press this epoxy in between there. Now you can get as fancy as you want with this because you've got 45 minutes to play with it. But the paint will cover a lot, so it's very forgiving. Use a satin finish or a flat paint. There's your basic idea right there. Now it's better to do this out of the car so you can lay it down in a position like so. So gravity holds everything in place. And then we just let it sit for a few hours and you're ready to go to the next step. Do this with the emergency brake cover off. Put the saran wrap on the emergency brake and we begin the epoxy process. Attach it underneath where it won't get in our way. And then a single layer of the material, stretch tight. Gives us the release layer we're looking for, and also reflects the contour underneath. And in this case, we're going to determine where it best suits our comfort zone. I'm pretty happy with it here. It allows us to roll the joystick with our thumb. So that's about where I'm going to want to mount it. This stuff gets gooey on your fingers a little bit, but it can just wash off later. Just don't let it harden on you. Just form it to the shape of the joystick, approximately. You can be, it's going to go over a round surface, so the center is going to be pretty much the thickness of the, like this. So you're going to get a little bit of a curve to it. You see that? So then you say, okay, where do I want this? Well, I found that right behind the button here is what works for me. And then you just very carefully press this thing into the epoxy. Now to keep things from moving around on us, let's just put a bead of tape around here. Keep our wire where we want it. And then simply form this epoxy to form an interface. Now, this stuff, it gives you almost 45 minutes of working time, so you don't have to leave it looking crude if you don't want to. The more time you take to finish it, the nicer it's going to look. You can blend it right in and make it look like it belongs there. Now, if you wet your finger, this epoxy gets slippery, and you can smooth it out like I'm doing here. Make it look really nice and smooth so you don't even have to sand it when you're all done. Wet your finger and do it over here. So you want to form it and then leave it alone once you get it contour fit the way you want it. So that's basically ready to be left to harden. So I'm going to leave that there for an hour, and then we'll come back and remove it. The MIMA display is a pre-made assembly that has the LEDs with a shroud around them. It's hot melted on the back, and it's purposely not finished because you want to, once you get the mounting finished for this, you're going to want to spray paint it. So I'm going to include a piece of aluminum masking tape that fits over the LEDs and a epoxy putty for mounting it. So I'm starting with a piece of saran wrap with a piece of tape on each end. Okay, so once the saran wrap's in place, there's actually two pieces of saran wrap here because we may get some on the front of the display. Okay, see the center red LED wants to be right underneath the C in the FCD. Now, the tipping of this display this way, you want to sit in your normal position, and if you're this way, you're going to not be able to see the FCD display, and if you're down this way, you may not be able to see the LED. So the trick is to get it so that the cover pretty much disappears and it becomes a very low profile. It sits comfortably right in position. The wiring from the display fits in this crack, and I found that this is the easiest way to get it in. You just kind of slide it in here, work it in, and then as you pull it down on the bottom, it comes out right at the very bottom, and you're set. The piece I'm going to give you should easily give you enough material to mount the display, mount the two joysticks, and have a little bit left over to play with. Okay.
Right.
Okay, so now we're going to take our epoxy and stick it to the back of the display. Again, we don't want this to be in our view, so keep it flush with the top like I'm doing there. This stuff sticks pretty aggressively to a raw circuit board. And this is going to be flattened slightly. Now what we'll do is we'll put it right in position. So we put that cable back down. Put this in position. What we're trying to do is get this down as deep as we can and right lined up with that FCD display. And don't worry too much about having it stick out the back very much because we won't see it, and the bigger it is, the more secure it'll mount to the surface. And sit back in your seat and adjust the angle to give you the best visibility of the FCD display, which is right above it. And once you get it the way you like it, you don't want to fool with it too much because this epoxy continues to change its shape as it sits. And also, very important you get it level this way because you're going to really see that later on if you don't. Now again, this stuff takes about an hour to really set up. It depends on temperature. Okay, that looks pretty straight. We can do a little sanding at the top if we have to. And it looks like it'll stay right where we put it. So we've got the shape pretty good. Okay. So we just leave it like that. Now that we've got all the epoxy work done, we can get back to the disassembly. We're going to start by removing this, finish the removal of this beam across the seats. Those have to come out as well. All right. Okay. And where the speaker is, it's a little tight. We don't have to move the speaker because it's part of that panel, but we do have to get this thing off. So there's one screw on either side of the speaker that has to come out.
Oh, I see it.
These screws could be quite tight, so it's important that you break them loose before you try to use any motorized removal tool. Okay, Ed's telling me that those screws are black, so it's a good way to identify them later when you go to put them back in.
Yeah, so don't mix them up. I don't know if they're special or what they are, but they're black.
So once those have been removed, that piece comes out. Be careful you don't damage your upholstery as you pull it out of there.
Yeah, sure.
And that gives you complete access to the wiring path that we're going to need to go through. A lot of screws in here. They all got to come out. The ones towards the edge are torque screws. That's taken out now are the 10 millimeter.
No, my drill doesn't quite have enough.
Don't forget these guys. It's 3 down below.
And then we notice the 6 around the edge,
And there's 6 torques.
3 on each side. Those are the Torx ones.
Now, some of these can be quite tight. A trick I found that works is if you can't seem to get them out without them wanting to strip, take a pair of vice grips and grab the large diameter around the edges and pull with that at the same time you're using the torque wrench, and usually that'll break them. And once they're broken, it can come out nice and easy. Yeah. So it's safe to take that
12
out.
volt battery's disconnected, so everything under here is dead.
This is what you're going to see when you open up the top. The little cover from your spare tire. Remove the spare tire, which you should know how to do anyways, because you may end up needing to do that at one point, so why not do it right now. Okay, so now you have a nice flat area to stand in. We pull this panel back, which gives us a fairly good access to what's going on there. And we take the connector, the flat part of the connector, fits nicely through there. So we simply drop it down in there. We can see the area underneath where it comes out, which we'll take. Okay, as we fish the wire from the top, you can see it here. Just reach in and pull it through. And that's it. That's all the wiring from the front to the back we have to be concerned about. Next, we're going to remove the connectors from the MCM module in the rear in order to begin the installation of the plug-in harness. These connectors are very difficult to pull out, especially if they've been sitting for a while, and you got to get your finger up underneath to press the little release button. And this tool actually helps a lot. Make sure it's depressed and then work it free. This guy has got a little push button on the side right there, which shows you how these connectors actually work. You see it? And this guy. Now, you notice I'm sitting in the back here. Turns out this is the best angle to get your hand there with your left hand to release it and the right hand to do this. If you try to do it from there, your fingers are all backwards. It's like it was designed to be worked this way. Now, this little tab here holds this harness in place. So simply pushing in on the side and pulling allows you to pop that out like that. Okay? Then you can pull this up like this. And that's the... I found that fishing this under here is a good idea. Then we attach it to this plug-in board, and it only goes on...
You can hold it. Turn it this way a little bit.
It only goes on one way. And you tie in these little things. So it's just like connecting it to a computer. And this thing sits down in here like so. And we simply plug these guys back in again. Now, you hear those clicks? You got to hear 4 clicks. If you don't hear them, you haven't got it plugged in good. Now this board sits nicely right down in between there. Take these.
Oh.
Now this goes in position. Now this is the fan control, which we will, if you notice, there's a little dab of dielectric grease in here to keep the contacts from corroding. And this gets pushed down into here. And watch out you don't cut yourself on this sharp seat metal. Might have probably been a good idea to put this thing in first. And then this plugs right into that. Can you see what we're doing, Paul?
Yeah.
Okay. Now this battery probe will be put into there in a second. Now we take these two probes here. This is the power inverter temperature probe, which goes over here. We want to route this as direct as possible because the wire's probably just long enough. I'm going to put some heat sink compound on there, heat shrink or heat double compound. Now we're going to plug in the special adapter I made for the current sensor. The existing current sensor is this middle one with 3 wires. There's the blue, there's a 2-wire and then a 3-wire. Now, these pins are very snug fits on these, so when you're putting it in, make sure you don't force it. It should just snap right in. And it actually locks in, and there's a release pin under here just like there was before. That little release is very difficult to reach with your finger, so if you have to use a tool or something small to push it in if you're having problems reaching it. Everybody's finger is different. Once it's plugged in, you plug this back into it, and now you're installed. Now we're going to install the battery temperature probe. To do this, we have to remove the fan. Okay, the fan has to be removed, and these little tabs that are up here are very easy to rip out. So I found that using a pair of vice grips like this until you break them loose is the best solution. So break them all loose. These all loose. This fan will come right out. Now we can look right in there and see the battery pack. Okay, to make room for this wire, which is pretty thin, we want to cut a little. See how these are loose? Bend them a little bit and they'll stay in place. Take a pair of cutters and you cut a little notch here in the fan casing. What that does is give this wire room to come in. Now you notice this thing is flat on one side and it's got a bump on the other. That bump is the actual temperature sensor. Now I'm giving you a little tube here of the thermal grease, which you're going to cut the top off of it like this, and then using this as a dispenser you can wipe a little bit right on there. This helps make a good thermal contact between the probe and the batteries. And now,
Alright, stop.
if you notice, there's a plastic case holding the batteries, and there's quite a bit of clearance between the case and the battery itself. So using the white thermal grease as an indicator of where you're going to go, just press this thing in until it makes a good interface to the battery. And that thermal grease will give you the connection that you need. Then you simply put this back on, and it should fit in there nicely. And tighten up the screws. Okay, now get the... Now there's little rubber pieces as that keep the fan vibrations from making a lot of noise. Make sure you don't damage those when you're taking this out. And you don't want to over tighten it. The screws actually have a flat bottom on them, so they can only get in so tight. I don't usually tighten them up as much as they were to start with. It's not like they're going to go loosening up on you. And then just a gentle snug. Okay. Now this fan is an exhaust fan rather than a fan that's blowing air into the pack. And if you consider that it's trying to suck air out this way and there's an opening all the way around the outside of it here, it makes you wonder what they were thinking, because you're going to suck air in here long before you're going to suck it from the front where the battery inlet port is. So what I decided was a good idea was to take some of this aluminum foil tape, which I'm supplying for you so you don't have to buy a whole roll, and just simply use it to block the gap and make sure you don't hit the fan blade, that's all. This stuff's pretty cool tape. Just peel the back off, and once it sticks to itself you're screwed, so don't try not to let that happen. And now you're going to get, I would say, anywhere from 10 to 15% better airflow through this battery pack simply by making it a better suction device and not letting air in the wrong place. And of course it helps if you got fingernails, which I have a tendency to bite off rather than keep. And there you go. If anybody at Honda asks you why that tape is there, just explain what I just told you. It's a poor design. Somebody got sloppy. The final probe is the temperature probe for the MPI inverter. And again, you put the thermal grease on there. And if you look down inside there, you'll see a little tapered area. This thing here, down deep in there, remains tapered. It turns out that's a nice way to measure the temperature of that heatsink. So I'm going to place this probe right down inside of there like this and use that like a thermal well to indicate temperature. And once you get it down in there, turns out this little bridge right here is such a perfect spot. I couldn't resist tying the thing down to that. Okay, and then cut off our excess. And there you are. Cover's back on. You're going to realize very quickly that this current sensor area sticks up slightly beyond what the rest of the unit sits up. So we've got to make a cutout in this piece of material. And we've determined that if we allow 3/8 on what you're seeing here as the right side and about a 1/2 inch on the left side and about 3/8 over the edge, that we can easily clear the sensor. Hacksaw cuts this stuff nicely. Supported off the end of the table like Paul's doing. Okay, now we've already scribed the line with the utility knife. Okay, and then it should just break right out. Paul's going to make sure and scribe the other side. Okay. Okay, and there it is. Okay, now we're going to put the cover back on, and we should have plenty of clearance for that sensor. And as we lay across here, there's no interference at all. The final wire dress for this area is a tie wrap here and a tie wrap here. The rest of the wires pretty well lay in position, and there's not much else you have to do. And then we can put the extrusion back on and put the rug back on and the cover, and everything's done. Now we're going to run the DB25 that we brought in from the back of the car over to the shift console. Here's the cable from the back. Now we're going to lift the rug, pass it through here. Because we've removed the seat on the other side, this rug has got a fair amount of flex to it. You just push it a little at a time and then reach the other side so you can grab it. When the wire comes through the side, we then pass it up to the front, and we will be plugging it into the distribution board. Let's talk a little bit about insulation displacement connectors. If you notice this connector, this is the end of one of our wires. A lot of the MIMA wires have one of these insulation displacement connectors on the end of a ribbon. If you look very carefully here, you can see that it just clips right on the end of the wire. I don't know how close we can actually get. There you go. That's just not bad. Now, how does this thing make its connections, and is there any issues with those connections? Well, these type of connectors have been used in computers and other industrial equipment for many years. It's really the fastest way to make a connection to many wires at the same time, and it does a pretty good job. Years of design and refinement have come up with these little plastic insulation displacement units that, if you notice, there's like little tabs that stick off of it. When we put that against the wire, we see that everything matches exactly. Each of those little prongs, as you push it through, pinches the wire in the center and passes by the wire adjacent to it. As long as it's put on straight, you should have no problems with this. But like anything that's dependent on friction, if the wire gets a chance to move like this, or gets flexed a lot when it's in place, you can have a problem with it wearing through and shorting to the adjacent wire. Now, this is not a common problem with these connectors because typically you don't allow them to move very much. We have one wire in particular, two wires. We have one wire in particular, which is the wire for the ECM, that has to pass under the rug next to your feet, and there's a possibility that that wire can get abraded up against metal. Now, this is a tough wire. You know, it's pretty rigid, but you get anything sharp and you start piercing the edge of this thing, you can have some serious shorting issues. So that's why we use something as simple as duct tape, which adds almost double the thickness that we have here of protection, gives it compliance, gives it some strength, some further strength. Should be all that's necessary to keep it from abrading against any of the body parts and causing a short. So the only other issue we need to be concerned about is to treat these things with a little bit of care and respect. Once these connections are pushed in, you don't want them to move at the connection point. It's okay if the ribbon moves other places, but you don't want it to move there. So you'll notice that on the ECM in particular, I've used hot melt to not only seal the edges of these wires, but also to immobilize it as it comes out of the connector. Don't yank on these things. Please don't yank on them like this while they're connected, because that will cause a problem. If you treat it gently, this thing will not give you any problems at all. Now, how does this actually connect to the wire? Well, you typically take the connector and you place it on the wire. It's made so that it has a slight detent when you press it in slightly. And then you can either squeeze it in a vise or, using a special tool designed for the purpose, you can squeeze. Now let's watch the process of squeezing this down. Oop. There are two latches, one on each edge, that engage. There and there. It holds the thing together, and as long as you were lined up properly when you put it together, and it's square, this connection should be just fine. But it's possible, if it was put together wrong, as I found, that you could have problems. So I've built this tester. Now, let me back off a little so we can see the whole thing here. So every one of the ribbon cables in MIMA has been tested with this device. Now let's look at the 20-pin connector. So basically I plug in my cable between there and here, and using this probe I go through. Let me adjust the brightness here a little bit so you can see this better. So I scan across and say, okay, only one should be lit up at a time. That row is good. Now that was me shorting across two terminals, so your technique here is important. So every cable's been tested this way. Once it's been confirmed that there's no shorts, and if there was a short, you'd see more than one light up at a time. This cable is just fine to use, and you shouldn't have any issues with it. But treat them gently, and you won't have any problems. Treat them roughly, and you could. And if you treat them roughly, then it's on your neck, because I'm testing these before I send them out. So if you've treated them too roughly and you have a short, that's why we have the waiver of liability. You assume liability for anything that blows out, and be forewarned. Treat them gently, you won't have any problems. Treat them rough, you could. This ribbon cable, while it's perfectly sound for electrical insulation and strength and everything, when we start running it underneath the chassis, I'd like to protect it. So we're going to draw a line right here and draw another line here where it's going to come out of the carpet, and then we'll protect the wire over that area so it's got a little better abrasion protection. Now protected the wire with the duct tape. You can see where one wire, where the sleeve comes over. The idea here is to get a couple of layers of more durable material over the outside, so if there is any abrasion, it will be not affecting the inner wire. There's moving parts in here, so we have to tuck the wire to the side and out of the way so that doesn't get in the way. And then we have to fish the joystick wire through the same opening as we did the other wires. When routing the wires, we have to make sure that they are not in the way of this attachment screw nylon insert. This is what holds the cover on, and if the wire's in its way, we could pierce the wire with the attachment. So get it down underneath, well out of the way. Okay, now we're going to mount the bracket that the MIMA board mounts to. We don't have to remove it, we just have to loosen it. Of course, it helps if you got a good wrench that doesn't keep flipping directions on you. As long as it's loose enough to get that little tab behind it, we're good. And you want to get all the washers on the outside. Poor Paul's in the most awkward position you can imagine here, trying to get out of the way of the camera while he's mounting this.
So that's how it goes.
Yep. And then you simply tighten up the bolt again while keeping the little notch right over that piece of steel. Okay. In. Next thing is to put the 4 screws in that mount the board, making sure that you have the board mounted in the correct position. You notice there's a piece of fish paper there. That's to protect that board from bumping that piece of upright there. So that determines where the top of the board is. Much easier to do it from this side of the car, but Paul's so good at this that he can do it from either side. Just watch his little screw handling technique. There's a lot of prior art that went into knowing how to do this well. You stick the screw on, use gravity to hold it there, stick it in the little thing. Tighten it up. Magnetic screwdrivers won't help you much because these are stainless steel screws. Okay, then you snug them up once you get them all in. Okay, and then what we do is we make sure that it's bent just slightly away from that, so there's no real hard pressure against it, but just there. Okay, mount the distribution board. Okay, now there's a little ground wire coming off of that, which is easier to do when the board isn't mounted, and there's some fish paper on the back to protect everything. So we're going to attach that ground to the hole that's already in the chassis. Put the screw in first, put the nut behind it, both of which have serrated surfaces on them, so they should break through any rust or corrosion and give you a good solid connection there. And since the serrated nut has a good grabbing ability on the back side, once you get this thing snug, you shouldn't have to really hold it. It should hold itself and you can get it nice and tight. Okay. There's a short ribbon cable with 10 conductors. That's the auxiliary connector, and that needs to pass over this beam and then down towards the back side. There you go, over and down. Oops, I hit the zoom here. Alright, there you go. And then that just plugs into that fire connector. And the other end is ready to plug into the distribution board. But okay, now we're going to route the DB25 cable that came from the back to the board, and just like we plugged it in on the other end, we make sure we got it keyed correctly, plug it in, and then snug it up, just like you would if you were connecting it to a computer. Okay, the connectors that you see on the the back end over here that are stock connectors, those wires may or may not be sticking out directly out. Some of them, they route them downwards. Either way, we have to make sure we have room to put the distribution board in between that and the back of the shift console. So pressing those wires down like this is not a bad idea. Now that that board just gently sits in there, we've got that in position. Okay, now we're going to put in this short 20 conductor ribbon, which completes the connections to the distribution board. So all the MIMA signals run from there into the distribution board, and then to the various components in the car where they're required. A small insert over the coin pouch in the car is where we're going to mount the MIMA kill switch. 1/4-inch drill, and right in the center. Okay, now let's go put the switch in it and mount it in the car. The wire, feed it down inside, run it across the bottom. We're going to mount it to the insert. You want the switch to be up when it's on, like any good circuit. Snug it up so it won't go turning on us by mistake. Okay, the switch is up when the wires are down, so that's on. And we're just going to simply pop it into here. And the MIMA kill switch is now ready to go. Once we get the wire run, we simply plug it into the small socket right there between the relays, and the kill switch is now ready to run. For this MIMA installation, I'm suggesting the use of double stick tape as a way to adhere the joystick and displays to their underlying surfaces. After doing 3 or 4 systems, I realized that this stuff here that I was using in my video is a little thin. It doesn't give you enough compliance between the surface you're mounting to and the irregular surface of the joystick or the display. So I'm suggesting that even though the video shows you using the white thin material, that we're going to change to this material. Now this stuff is a unique properties. It's kind of a foam, which means that it has a ability to move and flex and conform to the underlying surfaces. So if we take a little piece of this, we'll see that it actually has some kind of interesting properties. It's more of a rubber material than a tape. So as we pull on the material, you'll see that it actually has stretch. Look at the amount of compliance you have. So this means that as you apply this to a surface, it'll form to the surface, even though it's slightly irregular. And the adhesive on it is quite strong. So we have a situation where we might be sticking it more strongly than we need to. So if you're going to have something that's going to permanently stay mounted, like the display, you can use a solid piece of this material all across the surface. On the other hand, if you may want to remove it someday, you're better off putting 3 small pieces like this rather than 1 large piece. This gives you, because of the compliance of the material, you should be able to get something under the edge and be able to pry this off without too much problem. And because it's a rubbery material, most of the material will come off with the display. The joysticks are the same situation. 2 strips like this, rather than the full surface being covered, will give you something you can rely on as far as adhesion, and at the same time you'll be able to remove it if you have to, because it'll leave a slight gap between the inner and outer surfaces. And here's the other joystick. So basically, this is where I recommend putting the small strips. Don't use any more than 1/4 inch to 3/8 of an inch for each strip, and it should easily hold things in position, but if you have to remove it, you'll be able to get it off again. And so anywhere I show double stick, this is the way you should do it. And rather than redo the whole video, I figure this is better to just add this in. Okay, so here's what the display looks like after hardening. We've got the surface in the back that allows it to be mounted at the right angle. The epoxy's kind of just scobbed on there. Now what we're going to do is do a little sanding on it and see how we can improve the looks of this thing. Okay, a little sanding, and we've got this display now looking a lot more professional. So we've sanded it, blended it in, put the double stick tape on the bottom, and masked off the LEDs with the aluminum foil tape. We'll leave the corner of the aluminum foil tape up like this so we can grab it later and pull it off. And now we're ready to give it its final paint job. Here's the display after painting. Double stick still underneath. Now I'm going to remove that little piece of aluminum foil. There we are, ready to be put into the car. Okay, now we'll remove the release paper, and we'll place this right in position. Okay, there we are, lined up with the FCD display, just where we want it. We got to get this wire through this opening. So the best way to do that, I found, is to just grab a hold of the center, pull it out, off you go. That multicolored ribbon, or it could be a gray ribbon that comes from the display, plugs into that next connector. It's pretty hard to put them in the wrong spot because they only fit one way. And your display wire is coming down. Here's the display board, and I just simply tied it up to that wire that was next to the post, and then we run it down to the MIMA board. The last area we're going to work in is the ECM area. So let's start by removing the rug, and we'll access the ECM. Okay, so you start accessing the ECM by pulling out that panel. You'll see a couple of upholstery fasteners right there.
We just pop right out.
Okay. Now I usually will take those 2 out in the sill too.
Okay.
Now that we got the rug loose, we'll run the ECM to distribution board wire. So now we're going to take this wire, which has been protected with an outer covering of fabric, also commonly called duct tape. Pull the rug forward. This cable can go in either way. Both ends are the same. So you're going to be looking for the cable to come out there. So push your hand up underneath, and just with the tip of your finger, you should be able to get it to come through this little opening here. Okay, here we are. Plug that into the distribution board. Sure it's out of the way. ECM is a pain in the butt to get out. You got to first of all remove the carpet, and then if you notice way up on the top there's 2 bolts right there, 2 nuts, and then down on the bottom there's 2 nuts. So take those out first. Now, once you get this loose, you're going to find out that the whole ECM wants to come out with it, because it's bolted on the top by 2 screws that you can't get to unless you reach underneath. So, once you get it loose like that, now you have to get up underneath to get those 2 guys. Once you get that off, you'll see the ECM sitting there with all the wires. Now, just a little note here, these wires, the insulation's been the black insulation they normally put on these has been removed, because I didn't think we'd be able to fit things in there unless I did, but it turns out we can, so it's not necessary for you to get the wires down to this state. Just unplug them. Same technique as before. It's a little easier now because the thumb screw that you have to push is facing you rather than underneath, so you can't see it. The little thumb release. It's still a pain in the butt. Okay. Okay, so now we're going to plug this adapter into the ECM. You've got to seat them all the way in, so that click that you hear is important. One of those didn't click. Is it still in? Yep. Alright, silent click. Okay. Now the units that are going to come with the FAS relay, you're going to want to tuck the FAS relay up underneath the rest of the wires. Once that's kind of up and out of the way, simply replace the connectors back into the body. And they all are keyed, so you can't put them in wrong. But you cannot push them all the way in, which you've got to make sure you do have them all the way in. Did the blue one go in all the way, Paul? It seemed like
yes.
That. Okay, good. Now you're going to place it in position and lift the main body of the harness up over that clump of wires. No, the other way around. In other words, the big black, there you go, like that. And now tuck your FAS board up in the corner there. And the final thing is to attach your ECM ribbon cable, which is covered with that gray duct tape for protection, and that's going to plug into that little connector right there. Now we want this wire to be nice and flat against the floor. If there's any excess, you're better off putting it up into the center console here than you are to have it down in there. And now that we found that you need to do 2 things to this cover in order to make it work smoothly on the ECM. One of them is to remove this tab right here. The other one is to bend this out. So bending that out is pretty simple. Simple as that. You don't even have to have any tools. That allows you to pull the cover off without removing the ECM. The more difficult one is to try to break the spot weld that's attaching this piece. If you grab it with a good strong pair of vice grips right close to the bottom and make sure they're clamped really tightly, and then you use this technique that Paul's doing where you basically hold it and twist. You'll see that the part will actually twist right off.
Alright, let me pull the other side. It twisted halfway.
It twisted halfway. Now some of these are welded better than others. The first one I did just popped right off. The second 2 mangled pretty good on the top there before it actually came off. Another way to do it would be to grind off the weld, but that's a little more difficult and not everybody has a grinder. Okay, once you get it ground off, the trick here is you don't want any sharp edges, but if every one I've done, the weld has come off and it's been pretty clean. Like right now, there's no sharp edges, nothing to worry about there, so we're pretty much done. That allows the harness a new, to be routed in a new position, and it really doesn't interfere with the strength of the unit, which is mostly because of these ribs and the way it's mounted in the car. Remove the tab off of this cover and bent that upper piece. It should just slide right over the top of that without much problem. Okay, and you'll replace the two nuts up at the very top and the two nuts at the bottom, and make sure that that ribbon is routed underneath the other ribbon as much as you can, and you are now installed. So now we're pretty well ready to put the shift console back on again. Okay, the shift console is a little tricky because you want to get this wire through, but the joystick screws, the handle screws in. So you can't screw it in with it attached. So what we're going to do is leave the double stick tape in place, and we're going to fish this wire through the outside between this and this leather piece. So we'll take a look at how that's made. You'll see there's a rubber band in there that holds the material up against this little plastic insert. So we're going to just simply pull that plastic rubber band off, and then we can take this and pull it towards us, kind of like squeezing toothpaste out of a tube. You just squeeze it underneath and it pops right up through. Okay, then what we'll do is we'll take our joystick wire, and this time we've got to be careful that we have everything aiming in the right direction. So we'll start here, and since the joystick is going to mount this way, we just pass it through simply. This all can be done inside where it's nice and warm if you're in a cold place like we are here now. And once you get it more or less in the right position, it doesn't have to be perfect, you flip it back over again. And now we have to place this back in. Now you notice there's a textured surface, and it's a little smaller diameter than the shiny surface. The shiny surface is inside, the textured surface is outside. So we're going to just simply pass it in here and make sure we have the material slightly over the large surface area, which is the way they originally have it, and it keeps everything nice and snug. Okay, something like that. Right, it's close enough. See it? Okay, and it doesn't matter if it's at exactly the right spot yet, because we're going to take care of that when we do the finish. Now you take the rubber band and pass the material through it, or and then while stretching the rubber band as much as you can, get it over the material, and then make sure it's nice and flat. Alright, that's almost perfect. Now what we do is we take it and turn it over. And you notice the wire is a little longer than we're going to need. Well, you can just grab this and gently pull, and it'll move down. And we can adjust that in the final position once we get this on the car. Okay, so we've connected the wires, we've tied up the excess. We took this knob and I cleaned it with alcohol. Now, this is very important. We're depending on double stick to hold things in place. And double stick doesn't necessarily work very well if you've used Armor All or any of these cleaners that leave a residue of oil on the surface. So you got to take denatured alcohol. The best stuff is the 100% pure stuff. You can buy it at some hardware stores, and wipe this thing down and then let it dry. Then we're going to screw it on. Make sure it's snug and in the position you like. And then we peel off this double stick tape. Now this stuff is, if you remove this, you got to put new double stick on it. Don't depend on the old stuff to to work. You also have only one or two shots here to get it in exactly the right spot. And there it is. Fortunately, I got a little white across the top. That's why you should paint this thing very... Trim the double stick back from the edge slightly when you're ready to do it. Then paint it, and then you don't leave that white. Now the double stick gets stronger as it stays in place longer, so it's a good idea to wrap black tape around here. So this wire is nice and snug. We will, for the time being, tape it in position to keep everything snug. Then I'm going to use the black tape, which is stretched a little bit. We'll go around the bottom. That's good enough. I'll leave it that way for a couple hours. The warmer the temperature, the better off you are. And then that'll be on there until you rip it off. So this is what the final assembly will look like with the wire fished through, as I was indicating. And it's going to come out the bottom down here, in which case you can dress it up and plug it into the MIMA board. So tape up the excess joystick wire and tuck it underneath between the board and the shifter itself, and carefully stretch this out as you drop it down and slide it forward. And you're now ready to attach the screws, and your shift console MIMA controller is in place. Okay, once we get the double stick tape to adhere, after leaving it taped up for a while, we can remove the black tape. And if there's any touching up on the paint to do, a little magic marker does a pretty good job. Okay, we're getting ready to do the first start test, so we need to carefully turn the power back on again. Now we're ready to do the test. Remember that once the ignition is turned on, those two terminals are going to be hot, so you got no business being back here while we're doing our testing. At this point, all the connections have been made, everything's been put into position, but I wouldn't put anything back together yet until we get through the initial startup and make sure we don't have any issues. Okay, everything should light up. You'll notice the display is scrolling across, going back and forth. The MIMA display does not scroll back and forth. There's a problem. If you get a check engine or an IMA light, there's a problem. Any of those conditions, you should just turn the power back off again and give me a call so we can begin troubleshooting what might be wrong. If everything comes up and you see no codes, don't be too concerned about whether you've got a state of charge or not, because the state of charge circuitry will forget what the state of charge is when you do a reset. So if everything's good up to this point and you have no check engine lights, then we can proceed to the next step. If you have a check engine light, stop, figure out what the code is, and then let's talk about it and see if I can get you going again. Next we're going to start the car. If you had a state of charge on your gauge, the car will probably start with the IMA as it normally does, and if that's the case, then everything's peachy. On the other hand, if you have no state of charge, it will probably start with the 12-volt starter, and as long as it starts and doesn't have any codes, either condition is acceptable, and you can continue. This is where we try MIMA for the first time. We're still in neutral, the engine's idling, and we're going to press the assist joystick, and at the same time we should see the light come on, and then we should gradually, as we push the joystick, the electric motor will drive the gas engine and therefore show that it's able to produce power and it's under the control of the joystick. Seeing the assist activate with the joystick is your final test for MIMA. At this point you can button up everything in the back and in the front and get the car cleaned up, put the seat back in, and you're ready to go for your first test ride. Before you put the back cover back on, you'll need to flip that switch back off again and wait 5 minutes before attempting to put the cover back on. The MIMA system uses the car's own current sensor to determine how much current is flowing in and out of the battery pack, and also to display that information on the MIMA display. Green indicates charging, amber indicates assist. So current's going out here, current's going in there. Now if you find that when your car is warmed up, the batteries are charged, the lights are off, there's no electrical loads, that you still see a light on the display, either it be a little bit of green or a little bit of amber, it's probably a good indication that your car's bias on the current sensor is a little different than what the nominal is. It's not a big deal. All you do is you take the MIMA card and pull the shift console back slightly so that you can see this potentiometer. And then while watching the display, when you're in a known no current condition, adjust this potentiometer. And at first you'll see the light go out, and then you go the other way. So what you want to do is when the light first goes out, make a note of the position of the screwdriver, rotate it until the first amber light comes on, and then halfway between those two positions, set the potentiometer, and now you've zeroed your current sensor, and from that point on, it should work normally in both directions. The joystick calibration isn't necessary if you use the 2 joysticks or the 1 joystick that you ordered, because I calibrated here for that for the joysticks you have. But if you're going to change the configuration or change the direction the joystick's going to move, that's more convenient for you, then you have to go through the joystick calibration. But this is not a required step. It's already been done if you use the joysticks that you ordered. Be booted up. Okay. So now what you do is you press and hold. This only works if you stop now, by the way. So you press and hold this, and you'll see the standard brightness calibrate, but if you hold it for another 5 seconds, well, you get the assist LED, the one that says maximum assist. So you're going to press this in the direction that you want assist to be in. Then you release it. So now it says, okay, now I know what the maximum resistance was when you pulled it all the way this way, what it came back to when I released it this way. Now it wants you to show it what you want to have in this end of the pot. Once it finds a good reading, you let go, return to center. Now it says, okay, now I want the other axis. So when this light is on, if you jog it towards me, away from me, away from that. So it's just learned all the characteristics of that pot. But since I've got 2 joysticks, I have to duplicate the thing here. Now what it's doing is it's recording the values for these various functions. And then it's going to compute the best average to allow everything to work properly. So let's say I pressed the wrong way. See these lights? They say, uh-oh, that's not the right way, I ignored it. Okay, then you can continue with your calibration. Once it's done with the 2 passes, and if you have 1 joystick, you still have to do it twice, it reboots, and now you're basically ready to go. Start the car using MIMA. Now we're going to take a look at the MIMA calibration. This seems complicated at first, but if you look at the PIMA Mode 2 Calibrate Mode page of the website, which looks like this, with this chart, you'll see that the brightness is the first calibration unit we're going to get into. Now, this joystick here is how yours is going to look. Now, this is exactly the same as this joystick. Okay. Bottom button, top button, top button. My buttons just happen to be hidden underneath the leather so you can't see them. But if I press them,
they work. If you press and hold it, you get into the brightness control adjust. Now, instead of showing you this joystick, I'm going to use the one that's stuck to the car because it's easier to show you. So if you move the stick to one side, the display gets brighter. Move the stick to the other side, the display gets dimmer. Now, for the sake of the video, this one here shows you that they're on, and yet you can still see the colors fairly well. So I'm going to hold it there and then press at the same time. Click. Now when I release it, the brightness is still changing with this stick, because now you should see that the brightness of the display is that setting that we left it at, which it looks like it is. Okay? Now we're going to re-enter. Now we're back in the brightness. Now when you hit the first button, you're switching to what I call mag factor. Where you set mag factor is you take this thing and you do the same left and right thing, but this time you have to hold it down. So that's mag factor 3, mag factor 4, 3, 2, 1. 1 is so. Put it right there, let go. Now you've set the mag factor at 2. Next one is the ramp for the PIMA. The next is the ramp for the joystick. Since PIMA is hard to show you with the car standing still, but the joystick isn't, let's start by pressing the joystick, pressing it in the center, locked in a moderate, or the center value of ramp that's possible. Now ramp is how quickly you can change from one condition to the other. So I'm going to get out of the calibration and we're going to just jab the joystick quickly. Notice that it didn't speed up immediately. Okay. Remember that. We're going to go back to that step again. This time we're going to pull the stick all the way to this side and press it. Now we get out. Much faster, see? So it's how quickly it'll allow it to change. Now let's go to the other extreme just so you can see the difference. On this side now it's as slow as possible. Press the button. Okay, press it towards that edge. There you go. See how much slower? So the happy medium for both the PIMA, press it in the center, go to the joystick one, press it in the center. Okay. The next is your options. Okay. Option 1 is, do you want to have assist present when you're stopped or not? So if I press the central joystick now, that light starts to flash. If I get out right now and try to use the joystick, nothing happens. Let's go back to that same set point. Option, stop it from flashing. When we get out, now the joystick will operate the engine from a stop. That's what the first option does. Second option is the ABC swap. What that gets down to is you can set either the level of ABC or the position where it activates. Which one do you want to be the default? Okay, that's option 2. Now right now it's set up for the default, saying that the ABC level will be what you're going to get. Half assist. Some people say that full assist is more than they want to do, so I gave them half assist. Option 4, 5, 6, and 7 haven't been defined yet. So basically you've got brightness, mag factor, PIMA ramp, joystick ramp. Option 1, which is assist at stop. Option 2, what's the default going to be for ABC jogging, half assist, and this one, this one, this one, this one, and this one, whoops, haven't been defined yet.
Before we go for our ride, I think it's important that we get our terminology straight. When you start the system up, you're in the standard IMA mode and MIMA is completely out of the picture. If you touch the joystick, this is the assist direction, This is the regen direction. So when I say I'm pushing the stick in the assist direction, that's what I'm doing. This is the regen direction. This is the MIMA on-demand mode. You're in the standard IMA, you decide it's time to do something to give yourself a little kick up a hill or something, so you say, well, I'm going to just get a little assist. Now, if your hand's floating in midair and bouncing like this as you drive, you're going to have a hard time controlling this little stick. So what a lot of guys have found is very useful is to find a technique of basically grounding your hand out. So, for example, Ed Zandy took some epoxy putty and made a little ramp that comes down this way. And it's wide enough for your thumb to rest on it. So you rest your thumb on it, and when you want to make an adjustment, you just roll your thumb forward ever so slightly like this. Yeah. Now that's very precise. You can control that, you know, to the gnat's ass over here, just as close as you want. If you want regen, you pull it back, and that's a little bit shakier. But usually when you want regen, you want a lot. So assist, regen. Now this is the simplest mode to use MIMA, and it's the mode that you really should start off trying to use. As we go through using this, I'll stop, and then we'll go through, you know, teaching you the next mode on the joystick, and then we'll do it again. So this will basically our reference for what's going to happen after this, and we'll start with the simplest operation and then build ourselves up to PIMA and how to adjust it while you're driving, and then show some of the results you can. Okay, we're ready to go for our first ride with MIMA. Okay, we're going to start by giving a little primer as to how the standard IMA system works. For those of you new to the Insight, and some little subtleties that you may not have picked up on. I live at the top of a hill. This hill is fairly steep in one direction. And so when I go down that hill in the morning, I drive out, and I've got a half a charge right now. As we get on the downhill section here, I'm not going to be paying much attention to miles per gallon at this point. This is really just as a demonstration, so don't pay too much attention to what the numbers are. When we go to the real test, we'll show you what this thing can do. So now I'm going down the hill, and the stock system is just barely charging, as you can see by the green LED. I'm going to pull back the MIMA stick and lock it, do what's called a joy lock. So I basically pulled it all the way back and then pressed the central button, and now with my foot off the accelerator and the car just going down the hill nicely, I'm controlling my speed and putting all that charge back in my battery pack. Step on the gas, and as soon as the map signal, which is controlling that function, changes by more than 10%, I release the condition and go back to the standard IMA mode as a safety. So joy lock is meant to be a temporary condition. So I'm going to bring up the aspects of this system as we drive, because I don't have time to do this more than once. So coming to a stop. All of this is the standard IMA, so you can get to see how as you stop, you put your brakes on, it gives you some regen. Now we're going to drive through a country road here. It's Route 12 in northeastern Connecticut, near the town of Thompson. So we're going to use this road because it's a fairly quiet secondary highway. The speed limit's about 45, and it gives us enough straight areas and hilly areas to really show how different aspects of this system work. But right now we're driving as you could. I'm not using MIMA at all. I basically just used it to charge the battery so far. And as you can see, you know, the mileage is good, and I'm just driving at a comfortable speed for the road. Just as fast as I would drive with any other car, nothing special. As you take off, you get a little blip of assist, then it goes away. Oops, I gotta add a little bit of air to the air spring. You hear that bump? So we're going to pause this video right now. Okay, here we are cruising along. Nice secondary road, 33 miles an hour, and we're climbing a hill. Look at this. I got to step on the gas. Finally, when I get down around 50, I get a little assist. I'd much rather be up here. So with MIMA, you just lift your foot up until you get about 150 miles per gallon, 130.
give it a little bit of assist. And here you are climbing the hills, no problem. And you're using only 1 bar of assist. 1 bar or 1 light. There's 2. There's 3. There's 4. Haven't changed the throttle at all. Now, you're always better to be a little bit into the throttle when you're doing that, because otherwise the gas engine may be back throttling and causing a load that the electric motor is going to fill, and you're going to just waste all your power not going anywhere or doing anything. So you're much better off being in a high gear with a light load on your engine if you're going to use MIMA. Okay, so let's cruise down the road here at about 100 steady speed. We'll come into a little bit of a rise in the road right here. I'm going to just engage just a little bit of assist before we get to the hill. Make sure I still keep some gas going. Now as we get to the hill, I'll give it a little bit more. Now, there's a guy behind me, so I don't want to slow down going up the hill, but I sure don't want to speed up either. So I was able to keep it there at 100 miles per gallon, climbing this hill that normally I would have had to step down on to lower than 50 miles per gallon just to do that same thing. Now you'll notice the battery gauge probably took a little dip when I did that. Well, that's what happens. But at least you have control of how much and when you use it. Now here's another hill. Same deal. The guy's behind me. Stay at 40. Didn't touch the throttle. Climbing. Speed's climbing going over the hill. So there's a lot of torque from that electric motor. Torque comes from amps. So you got to watch your amps in and amps out quite carefully. Now, here I am coming down a hill. My foot's off the throttle. Engine braking, but I'm going to pull back on the stick and I'm going to put back a lot of that juice that we just lost and lock it in. Coming to the stop sign, coming to the stop sign, coming to the stop sign. Suck it right down. Okay. That's it. Joy lock is released. Assisted blaster. The hot rod mode of MIMA. The hot rod mode. Okay, put it all back whenever you get a chance. Put it back. I think I can brighten up that display a little bit, so I'm going to press the display brightness control here. Yeah, that should give me a little better visibility on this bar graph. So now we're going to a big hill here. This is like a monster hill. I'm in second gear right now with the thing floored, the standard thing, and it gives me assist, all right? Watch, pretty soon it drops it to 3/4, and then it's going to drop it to half. With MIMA, I can keep it there. I can keep it there the whole time. So you basically are using less gas because you're getting up the hill faster with less engine work and more electric work. Okay, in this segment we're going to talk about ABC and MIMA Active. MIMA Active is where you want to completely take over the control of the IMA system from the car, and you don't want the car to be able to control anything. The downside of this is that if you need a charge, there's no mechanism in place to do it if you just left it be off. So we came up with this idea of having it be an adjustable background charge, so that in this particular mode you'd only charge automatically and you'd have to use assist manually. This gives you the ability to make the MIMA system act like a diode, where it only lets charge come in and it won't let it go back out again. So even though the amount of charge could be quite low, so it hardly affected your miles per gallon, the effect on your electric use would be quite small. The car typically puts a background charge on. As you can see right now, there's a background charge going on with the stock system. It's about 2 bars when I decelerate. You get a little bit of assist when you try to go up this hill, but not until you're down to 50. I mean, look, I got the thing floored and it's only giving me 2 bars, and it's probably getting 20 miles per gallon. On the other hand, the same situation, just give it a little bit of this, And now I'm climbing that same hill and accelerating at 90 plus miles per gallon. So the idea of getting the battery charge back in slowly so it doesn't influence your driving or your miles per gallon, and yet have it gradually accumulate, made this ABC seem like a good idea. So I'm going to activate ABC right now. You notice the first LED lights. Now you notice there's a charge going on right now. It's about 2 bars, very similar to what the car was doing by itself. Let's say I want it to be less. I just jog the stick to the right, and now the maximum level is quite low. It's just barely lighting. Jog it some more, and I can increase it until I'm at pretty much 2/3 of the maximum, or 3/4 of the maximum regen. Now, as I move my throttle up and down, we see that this, I'm going to have to turn around here. Hold on a minute. Okay, we're cruising along on this nice back road, 45 mile an hour speed limit. We're in 5th gear, going 39 miles an hour. You see that the background charge is quite high. So I'm going to jog it down. The LEDs, the last LED that's lit on this MIMA display actually changes brightness based on how strong that number should be. So if you've got about 20 different levels of illumination that you can get before the next LED comes on. So there's quite good resolution. I'm just looking at brightness now. When I step on the gas and it reaches, in this case, about 60 miles per gallon, regen is totally removed. Now if I want to add a little assist here, it wouldn't be a bad idea. Then I can actually raise my miles per gallon back up again and let the electric do the work. And by now I've already picked up some charge from this background charge, and you can see that I'm up there. And as you start going downhill, you can jog a little bit more in. Right now, I was just trying to cruise along and get some good numbers here. Not really using assist hardly at all, but because I can get the regen down to a quite low level, it just trickle charges this main battery at a very slow rate. Want more, I just give it a couple of quick jabs to the left, a couple of quick jabs to the right, it goes back down again. But the trick here is that there's a point where it kicks in. Now, let's get enough so you can see it here. Now if I step on the gas, you're going to notice that it's just going to abruptly go off. Boom. Okay, and abruptly come back when I let back off again. So I'm saying about 65 looks like the right number here, but with the sun shining this way, we can't really see that. Should be all right in a minute. All right, there we go. Okay, so there's a light coming up. We might make it. Give it some gas right there, about 65. Now let's say I want to shift that to 50 or some other number. Well, I only have one forward and reverse on the stick as assist and regen, so I can't use that axis for adjusting that. And I've already used the left and right axis for setting how strong the level is. So I had to have another way to use the left and right for a second function. So if you pull the joystick to the left or the right and you press it, you're going to see that first LED start to flash. When you see that, you're now still operating just like you did before with the ABC, and the regen is coming on after it crosses a certain point. But now you can adjust where that point is by jogging left and right. So if you jog to the left, it's going to move the set point to the left down towards 50 rather than 60. Yeah. Jog it some more, it's even lower. So this way, it'll only kick out the regen on a very steep hill or a high acceleration. And the rest of the time, it lets the regen ride. Once you get that set, you just press mode 1 again, press it again, and now you're back in the normal ABC mode where you can set the level. But now it's going to reflect that new set point. Here we are coming to a stop. Now why not just use it all by pulling back on the stick? Because MIMA on demand is always available in mode 1 as well, which makes it a nice tool because you can use it for charging your battery and still get good mileage while doing it. But you have to be in control of the assist. Now I got to blast off here because there's a guy on my ass. So that's another nice feeling when you can just goose it like that. And you got a 3/4 battery, so you got the speed much faster. So even though you had that nice kick in the pants that feels so good, you and you drop some miles per gallon, you've got most of the torque from the electric motor, so it really just has to be trickled back in again. Now I got a fairly hefty background charge going right now. I normally leave it down around 1 bar, or just barely 1 bar that's not even fully on. What this does is it makes it almost invisible. You can cruise along just like you had no IMA operating, and you don't need the IMA, but in the background it's putting just a gentle little charge into the system. And then you can see the gauge is still up there at 3/4, even though I just had that burst. Now, here I am coming to a little rise in the road. I'm trying to hold my miles per gallon up there, but this rise in the road is going to cause me to have to step down on the gas again. So, a quick jab with the MIMA stick, and up we go. We're actually accelerating up this hill, and give a little gas so that the engine's not being back driven by the electric. It's actually helping the electric. So now you got both systems on very low power pushing you at a nice comfortable 40 miles an hour up the hill. Okay, I'm coming to a more residential area where we're going to slow down, so I just pull back on the joystick and let off the gas at the same time. Or if you want to put more charge in, you leave the gas on as you decelerate, and then you just pull back on the regen. This way, you're taking and adding a little bit of gasoline to the mix, not very much, because you're still up over 100 miles per gallon, but you're extending the length of time that you can charge your batteries, because you've got full assist on, or full regen on, whereas normally you'd only be able to have very little, otherwise you'd lose speed too quickly. Power charging. Programmable mode of operation for the MIMA system, and it's probably the one that's closest to the way that the standard system works. As we saw in the previous video, the standard section works by basically giving you assist from the electric motor whenever the load on the engine exceeds some certain value, and the amount of assist is proportional to how far past that value it passes. With PIMA, I do the same thing, except that the place where it activates and the speed at which it actuates are both adjustable. And they're adjustable by moving up and down the miles per gallon scale with the set point. If you consider that the stock system set point is approximately 50 miles per gallon, which is where you first see assist kick in under most conditions, this point can be set as high as 150 miles per gallon in the PIMA mode, which means the electric would be on all the time, which of course is not which is an undesirable condition, because your battery wouldn't get you very far. So typically I find for me, I can set that at a little bit above the average miles per gallon that I expect to be able to get for the road, and that way gives me the best balance between electric assist and battery life. You can shift that ratio slightly higher or lower depending on what you're trying to do. How do you shift things? How do you change things while you're driving? This creates a lot of confusion for people. I've got some visual feedback on the display that's not obvious, which we'll go into when we actually start driving. But basically what happens is in PIMA, since the map signal, or the miles per gallon signal in the case of the display, is activating or deactivating MIMA and going into regen or not, based on what the map display is telling it that the miles per gallon is. If, for instance, you consider that a jog in this direction or a push in this direction with the standard MIMA would give you more assist, consider that in PIMA, a jog in this direction increments the amount of assist you're going to get at the particular miles per gallon that you're going. So if you're going 80 miles per gallon and you're getting 1 or 2 lights of assist, jogging it this way once will increase that, increase it again, jogging it this way, which is back towards how you used to get regen in the standard mode, you're actually lowering the amount of assist towards the regen direction. So this is moving it towards the assist, moving it towards the regen. So that takes care of the assist function, but we have to be able to set the regen as well. So the regen is a little more complicated, because based on how you set up your joystick, this may be more or this may be less. So I've given you visual feedback on your display. If this is the jog direction that you chose to be jogged down, what will happen is the regen, the first LED, which is the one that comes on when your regen first starts, will light up, which is indicating the low end of the scale. So this would say I'm going to go lower, lower. If you press it this way, the last green LED, the one on the far left of the display, which indicates maximum assist, regen, will light up every time you jog, and that shows you that you're moving upscale. And the same thing happens with the assist direction. So by watching for that little blip, you can say, oh, I'm going up or I'm going down in the amount of regen or the amount of assist I'm going to get at this point. Once you get that straight, it's pretty easy to do, and you don't have to almost think about it after a while. Your thumb just knows which way to go. So let's go for a little ride. So let's watch the normal operation of the IMA for a second under this particular driving situation, which is going about 36 miles an hour, as we can see, on a back road. I'm stepping on the gas now because there's a little grade increase, and the guy behind me wants me to keep going the same speed, so I do. You can watch the gauge jump up and down and reflect what my foot is doing. So now what we're going to do is we're going to kick on MIMA. Now, as you watch here, nothing really happened. Why? Because my foot is up around 125 miles per gallon, which is above where I've set any of the set points. But watch, as soon as I step on the gas, look at the assist come in. I get to 100 miles per gallon, I've already got assist going for me. Don't need much either. I'm trying to keep my 36 miles an hour. Don't need to go faster. Now, I'm climbing a little hill here. Okay? If I hit the joystick right now to try to give it assist, what I'm really doing is I'm jogging in more assist. Now you see those lights flash, every other one? That means I'm up against the limit. So I'm going to jog the regen down. Now I can jog the assist up, and boom, I can feel it. All of a sudden, here I am at 150 miles per gallon, and I'm getting assist. And I got full assist by the time I'm down here. Well, that's a little more than I wanted, so I jogged the stick back in the regen direction, and there I am. But you get the idea. And I'm letting off the gas. It automatically puts on regen. By jogging the stick, I can move that point up or down and cause less regen or more regen. So you got total control over how the car responds with the assist system, all automatically. Okay, we're cruising along 45-mile-an-hour highway. MIMA turned on. Full charge in the battery. So as I'm driving here, you'll watch that as my miles per gallon drop to about 115, 125, I start getting assist. By the time I get to 100, I'm almost fully there. But you don't need that much to keep going here. I'm going to stay at the speed limit or even slightly above it here. Maintain 100 miles per hour. Now there's hills here. We're talking about some serious up and downs here. Just crested a hill. Now this is the point where we're pretty much full. Got a good charge in there. I'm putting more in, but I don't really need it. So this is where I would press the button, put it in neutral, do the FAS. So now we're basically coasting at 50 miles an hour in neutral without any gas being consumed at all. Now, of course, I can't charge the battery either. So that's the advantage of FAS. If you got your battery charged, it's a good thing to have as a backup for where to put the energy. Just coast. Okay, now as we start to slow down, I just touch the gas. Engine starts back up. Put it in 5th gear. Continue along as though nothing had happened. Put MIMA back on. Another hill here, a pretty good sized one. And we're cresting another hill. Not cresting it yet, but we're just on the bottom of it right now. fifth gear now, doing 40 miles an hour. We're basically at only about 1,200, 1,300 RPM. So that engine isn't producing much power, and the electric's doing most of the work. And that's why we see such a number up there. Now, like any situation where you're taking energy out, you got to put it back. Now you notice I'm not getting regen even way up on the top of the scale here. Continue to get assist up over 100. I want to lower that assist a little bit, bump it back 2 notches, then bump the regen over 2 notches. Now I can get regen to come on a little sooner. We're not getting assist until we're down around 100. Just over another hill there. Now I can pump a pretty good charge back in and still maintain my speed going down the hill without touching the MIMA stick. I'm just doing this with my foot. A little more speed, so I don't lose as much speed. I get a little less regen. I can also jog the regen up so that I get no regen up there, or very little, so that I can limit the maximum regen by what I do at the very end of the scale here, and then assist stays right where it was. So I'm losing my 45 miles an hour speed limit here, so I'm going to build it up on this next downhill, keeping it into the assist area. Stoplight coming up in a little while. Up a little grade here. Over the hill we go. No more assist than necessary. Since I know I got to stop here pretty soon, I'm going to just put in as much regen as I can now as I approach the stoplight. A little bit at a time. I don't want to lose momentum too much. I can even make it more aggressive here. Okay, I'm going to stop for a minute as I go through this light. Well, I got a green one. I guess I can keep going. So I'm going to downshift into third up. We missed the light. Here we are at a stop. We go into auto stop as we should. The light's flashing to tell us that we're still in the PIMA mode. So it's once we get up to 19 miles an hour, we're going to be going back on PIMA. Let's pause for a second. Notice my car sounds loud. It's because I don't have any exhaust on it. Took the muffler off and put the fifth wheel in its place. Let the PIMA do its thing. Just keep your foot out of the throttle and just get as much acceleration as necessary. Now we're going to slow down. Again, no brakes involved. Got a green light. See if I can make it without downshifting too much. So now we're going through to another light, which leads to a little 25 mile an hour town. Remember, the PIMA has been adjusted for 5th gear, and I'm now driving in 4th gear and 3rd gear, so it's not really optimized as far as coming in at the appropriate moment. As soon as I get over 50, things will start behaving again. I'm going to back off on the regen and give it a little more assist here so we can keep this mileage up, because this is the kind of stop and go area that you can really lose it. We're almost down to 100. How terrible. This is like the last light before we get into another smooth area here. Watch it, we're going to run out of charge if we don't take it easy here. Whoop. Just saw a lightning bolt, a thunderstorm going on, right where I'm going. So now we're kind of getting out of the other side of town here. Looks like we need to get some charge back in here. Now, I can continue to play PIMA games and get these big numbers. Or I could go into ABC right now and just kind of baby things. But I think I'm going to stay in this mode and see if I can get a little more regen out of this thing. I think I have to lower the assist a little bit and get the regen down a little bit. Now I'll be able to get regen at a reasonable throttle. Notice how the assist comes in and then it will fade a little bit. This is as the car responds to the increase in power, the load drops and then the map will back off. So you gotta watch that carefully. The road is wet here. It looks like we got a little bit of a thunderstorm through here. What I'm doing now is using the downhill and my throttle to give me a moderate regen down that hill. Since I don't have to go very fast, keep up with this 35-mile-an-hour traffic, I can play this game a little longer. Now this is where having a boost system would have been putting a charge back in, and since I'm not using it that quickly, it would easily be able to replenish it. So right now the gauge would be probably at half full if the boost system was on, with the type of driving I'm doing, rather than where it is now, it's just barely off the stop. Another stoplight. .6. Pick this thing up again now. We got the 15 miles now. A few lights, few hills. One more town. Here we are. Cresting another hill. Come on, baby. Come on. You can make it.
95.4. See if we can get it back up there. It's kind of rough. This is a pretty winding, pretty hilly section of road here. Give it a fast jab, the map changes faster and it gives you a jab of more assist. Another light. Can't seem to miss them. A slight grade right now. So PIMA works pretty good as long as you get some charge in that battery, and that's the trick, is to keep it in there. You gotta lift your throttle up into this high mileage zone in order to get it to kick in, or you have to jog it down a little lower. This is cruising around at low speed MIMA. PIMA activated. This type of city driving, well, the speed is right. With all of this back roads driving, with the speed is good, but the terrain is pretty nasty. A lot of traffic, a lot of lights. This method of driving is extendable for quite a long ways, as long as you have about 16 to 20 amps of boost charge coming in. In this case, I'm running it off the stock pack without any boost. This is a pretty good sized hill we're trying to climb right here in high gear, so burning up a serious amount of fuel here. Electric fuel. Notice how long my pack is hanging on there. Now this is a pack with 100.
flat. There's a couple of hills. We just passed one big one. Now we're pretty much on a flat ground right now. But on the flat, you can see that you can maintain this kind of speed quite easily with not a whole lot of assist being added. You get up to 75, it's another ball game. Now you got to work a little harder because the air resistance is up a whole notch. Okay, we're in Webster, Mass now. A couple more exits and we're going to get off to go to my house. See, the car has no trouble keeping up. Every once in a while you got to give it a little bit of extra electric here to keep it going. I'm gonna back off a little bit on the assist right now. Give it some more regen. Coming to a hilly area here. Granted, that's only about 5 or 6 miles, but the idea is there. You know, with enough electric being applied by the booster pack, you could continue at 100 miles per gallon at highway speeds. 65, 68, maybe even 70 for a fair distance. 45 minutes to be exact with my booster pack. So that's 6 miles. It's taken about 3/4 of my pack. We're still going. Still getting some strong electric priority. Another hill. Give it full assist, nothing happens. Basically, assist is limited, regen is not. Okay, turn MIMA off.
MIMA is now installed, and you should have your MIMA grin running by now. If you have any problems, don't hesitate to give me a call. I'll do what I can to help you. And thanks for buying the system, and I hope you enjoy it and your mileage goes through the roof.